All right, thank you. Checking. That's advanced. All right, well, it is 1:29, so we'll give 1 minute, but as you're settling down, please see if you can move up. We have a very small audience. It's a huge auditorium. I think the speakers are always encouraged when they see you and react to their talk. So, if you need a carrot, David Unkefer here from Federal Highway promised more federal aid money, waiving all your research requirements from states, all kinds of freebies, so no takers for that? Come on. Well, so, please, as you settle down, just try to be in the front section so we can see you. So it's 1:30, so I'm going to go ahead and start. Welcome to this session. It's really exciting to talk about digital twins. We are in this session. My name is Jag Malela with WSP. Honored to be the moderator, and we have some excellent speakers here. One of them is going to be virtual, 2 here in the room, and then 1 substituting, David substituting for Aaron Costin. So there we go. Thanks, Jen. Freebies are always good. More money, more federal aid dollars flowing in. So I wanted to set the stage for digital twins because a lot of us have heard the term. It's easy to talk about it. It makes sense, right, intuitively, but it makes sense. Different things. It means different things to different people. And I just threw up this graphic, and everybody calls it something else. Every time I turn around, people have a different definition of what a digital twin is. I just want to set the stage. I'm not supposed to be making a presentation here or stealing the thunder from our speakers, but why is it so hard to define it? Because we all have different uses for what we are calling digital twins. It's a single point of truth, according to some. It's a collaboration framework, like a BIM framework. That's why we are here. It's a BIM track digital twin. So absolutely, a digital twin is a collaboration framework for data and data sources, both static and dynamic. There's diagnostics involved. People use it for diagnostics. There's predictive, proactive modeling. That's part of it. Customer experience, AR, VR, MR, and remote training. So there's different uses, and that's what makes it hard to define what it really is. But I threw up a definition here mainly because I think the speakers will speak to aspects of it. This is my definition, so that's why I have WSP on it, because I don't want to take away, for you to take away the TRB's definition. It's definitely not a scientifically researched one, but it is definitely based on a lot of publications that I have parsed through and have looked at literature. And there's an excellent meta-analysis of research, that was done on what digital twin means. So the research states it's a virtual construct that represents a physical counterpart. We all can understand that, right? It's a virtualization of physical world. It integrates several data inputs for handling, storing, processing. But I think the 2 things that at the bottom are really important is provides an automatic, and the word is bidirectional, data linkage between the virtual and physical worlds. That's almost a requirement in my view. There's got to be interaction, not just representing something on your computer, but the computer should be able to tell the physical system that something is happening, change your behavior. Yeah. And also the second one, the last one is, it's a synchronized to display changes in the state of the physical object. So it should be in sync with the real world, with the real updates. So at least that's my definition. I'm so glad that I looked at the presentations today, just a quick sneak peek at them. A lot of the presentations today talk to different aspects of this, but all of this is correct, and there is nothing wrong because we're in a state of evolution, I think. Some of us are in the basic stage where we are just creating a physical twin, then we are moving on to enhanced, where we are doing basic plus some process data. Eventually, we'll get to autonomous control, maybe enhanced autonomous control with no physical interaction, with no people in between. The autonomous control has a person. And then exhaustive, which covers everything under the sun. So obviously, we'll never get there, I think. But with speakers today, I think we can get closer to that. And the first speaker I have is Terry Bills from Esri, and he's going to make a presentation. He is the Transportation Industry Director at Esri. He has over 30 years of experience in transportation planning and policy, information technology, and GIS. Terry has been with Esri for 18 years, where he provides subject matter expertise and thought leadership in his transportation. So without further ado, Terry, please come up, and please welcome him.
right, thank you. And let's see. I actually want to start really with what I would call digital delivery and then move into digital twins. So I want to set it into context. With the infrastructure bill, we're making really a once-in-a-generation investment in our infrastructure, and most of you are quite familiar with that, so I don't need to go into that. The problem is that our infrastructure is probably the most expensive in the world to build. Few examples. And so obviously we need to look at how we're going to get more bang for our buck out of our infrastructure dollars. So this was a study published by NIST about 6-7 years ago, really interviewed a number of architectural and engineering companies and really looking at some of the inefficiencies. So as any engineer will tell you, about 40 to 60% of his time is really just locating the information that he needs and validating it. That if from the beginning of the project we took our information system seriously, that we could actually reduce the delivery time by 20 to 50%, and ultimately that it's the lack of communication between those systems that really wastes about 30% of the total project costs. So when we look in our European colleagues, they're actually, by following BIM standards, they're actually saving between 15 and 25% of the total project cost. So the real irony is that they're doing that using our technology, North American technology. They're using Bentley, they're using Autodesk, they're using Esri, they're using Trimble, and they're figuring out how to integrate those technologies to achieve these savings. So we need to do a better job. We need to be more effective, and we need to look at how we can emulate their successes. So many of you are familiar with the infrastructure lifecycle, the different technologies that we use, and really what digital delivery is all about is how do we better integrate all of these technologies as we move from planning into design, construction, and ultimately into operations and maintenance. And that's really the goal of digital delivery. And we are working with any number of state departments of transportation that are really trying to solve these issues. We all understand that we use GIS in planning, and then as they say, when we go into design, that's where data goes to die. And so let's not have it die. How do we begin to capture that data? And so I want to really sort of talk about some examples of that. So one of the leading examples is actually the Utah Department of Transportation, and they've been very specific. They brought together all of their vendors, and they said, really, we need to solve this problem. We need to solve the problem as we move into design and construction, and we want these technologies to work together. And one of the wonderful things about Utah DOT is that they have a good history of really trying to bring their consultants and their contractors together and say, we need to together figure this out. And so that's actually what they did. And they really defined this, it's really a 12-step program. And so the first 2 steps are really, they have their CAD standards that every design has to come in, has to follow their CAD standards. And the design has to be uploaded, and it has to actually be validated against those standards. So they actually literally do that. Every design gets uploaded, gets tested and validated. Then the next step is that they actually attach the pay items. So everything that they're going to pay their contractors, each task, each item, the pay items are attached to the literally to the DGN file, and in turn validated against, in their case, they're using Origo, so those are validated so that every pay item is now attached to the design. And now that comes in step 6, that's brought into the GIS. And so literally all transformed into the GIS in a way that now they can take that out into the field so that they actually have the pay items on the mobile devices that they take out into the field. So they now require their contractors to use the mobile devices in terms of not only their staff, but the contractor's staff to do all the inspections, daily inspections, and ultimately the step where they really want to go is step 11 is now, once I have actually the as-built, the digital as-built, I'm going to really move those over into the asset management and literally into operations. So they have taken a great deal of time and effort to really go through that process and to really understand all of the tasks associated with their design and construction inspection process. So here's the mobile device that they do actually two sets. They have a daily inspection, daily progress report, and then they have the construction progress inspections. So literally on the tablet, they actually have all of the pay items. They actually have all of the design elements. They actually have an RTK device that then gives them several centimeter level accuracy, so survey grade accuracy in the field as they're doing the inspections. And this is part of their normal process. Not only do they have that level of accuracy, they can access any of the station data, and that station data in turn can be correlated with their linear referencing system. So all of that literally on their device, on their iPads in the field. So what does that look like? And so that was Utah. I'm now going to show you Caltrans. So Caltrans is following a very similar process. So what you're actually looking at is a section of the 101 corridor through San Mateo. The blue area that you see there is actually the bridge design. It's brought in from Revit. The road and all the culverts and the guardrails and sound walls are all brought in from Civil 3D. The white line that you see running down the freeway is actually their linear referencing system. So I now have the ability to pull in all of the agency's data, attach all of that data literally to this digital design. In addition, all of the buildings are actually taken from real building heights and all of the trees, and that 3D model was actually generated in an afternoon with our procedural technology. So literally, this is what Caltrans is going to put together for their entire system. So in essence, what you have is the ability to bring together all of these disparate elements. They have the traffic cameras, the automatic traffic recorders, any other real-time information. All of that is linked on this digital file. Give you a sense, here's that bridge again. You can see the culverts, and then not only do you have the bridge, but in fact, all of that Revit information is now available to me on that tablet. So literally, I'm looking at the pedestrian guard, and I can have all of the information taken directly out of the Revit file, the Revit design file. I have that on my laptop, I have that on my tablet, I have that wherever I need to have it. So for all of their design data, I take it into the field. In this particular case, the area on the right was the existing sound wall, so we've made that transparent, and the area on the left is where the new sound wall was going to be installed. There's the sound wall, there's all of the subsurface aggregate information, and again, all taken directly from the Revit design. And there's a profile of my pavement and including the different layers. So again, all of that I have in the field with me when I'm making my inspections, and I can actually see the different layers. So ultimately what that provides them is really the sort of the 3, 4, and 5D analytics, It allows them to do all of the site inspections. It allows them to generate the as-builts and capture those as-builts. And ultimately, it gives them the collaboration framework so that multiple contractors can literally work off of the same data. And each of the teams ultimately has their own set of dashboards. So whether you're the project management team, whether you're the environmental team, project controls team, you actually have your own set of dashboards that you're using to monitor those projects so that you can ensure that they're done right, they're delivered on time, and on cost. So ultimately, out of that process, out of that digital delivery process, what you get is, again, that comprehensive collaboration environment. You can move relatively easily from BIM, CAD, and GIS back and forth. And ultimately, you're doing your design validation and your review. And ultimately, what their real goal is, how do they optimize these processes? So again, if you think back to the cost of our infrastructure, how do we use technology effectively to bring down those costs? And how do we de-risk our projects? And ultimately, the goal is how do we then, in turn, take all of that information and seamlessly feed it into our operational systems. Okay, so with that, now I'm going to shift into the digital twin, and I'm going to show you some digital twins. And I don't want to be the person to put the bad stuff into the punch bowl, but let me just point out that I think Gardner has identified that digital twins are probably at the peak of inflated expectations, and I think we're all in for a bit of a fall to the trough of disillusionment. And I think that we need to be very careful, and we need to think very carefully about our digital twins and what we're going to do with our digital twins. And let me just sort of emphasize that from this quote from Gartner as well, that, you know, digital twins are not easy to build, they're expensive. Unless you have a real clear business case ahead of time that you've defined, I think you're going to have some real issues. That these are, and I'll just leave it at that. But I think that there's going to be, I really do think we're going to have a lot of disappointment down the line. And I think we need to be very careful about the way that we build these and the way that we think about digital twins. So, and to sort of reinforce, we can create a baseline or a historical record with a digital twin. Ultimately, I think I'm going to show you a couple of examples of operational performance, so that I'm going to show you an airport that's actually using their digital twin to monitor their physical plant in real time. And then ultimately, how do we use our digital twins to really do predictive modeling and test scenarios against those digital twins? So if you think back to that Caltrans example, what they really have, in a certain sense, is a digital twin of their network. So with that, in fact, now I can move into safety analyses. How do I do better design, incorporating safety, corridor studies, operations. So what I have created is a physical infrastructure against which I can really model any number of different scenarios. Again, just another way of saying these are really some of the business drivers. And again, I think we need to be very clear about what those business drivers are when we're building our digital twins. So here's just an example. This is the Houston George Bush International Airport, their new terminal. So literally in an afternoon, we were able to pull that Revit file into the GIS, and now I have that, I can make that available to anyone on any device. So literally on an iPad, I can pull up that Revit model and interrogate any item in that design. As another example, the LAX has, as most airports around the country, has literally, dozens, if not hundreds, of capital improvement projects going simultaneously. LAX was struggling with how do they make all of those Revit models available, and how do they share those models between teams. And so after they had failed a couple times, we showed them, pulled all those Revit models from across LAX, put them together, and they're served out literally on a tablet like this. So again, I can interrogate, so anything that I click on, I can pull up all of the details directly from the Revit model, and including I can look at chairs, and normally we show you that there's an electrical fixture there. I can actually click on that and pull up all the details. So any of the details from the original design you have available to you, and literally again on any device. And that includes not only inside the terminal, but exterior. So in this particular case, again, we're really looking at a lighting fixture, and literally I have the entire airport modeled in three dimensions. So that was really the design criteria that SFO, as they were going through their capital projects, they had about a $7 billion capital improvement plan, a number of projects, and they really again thought about how do we manage that data and how do we create an infrastructure that's going to last another 50 and 60 years through that full life cycle. So again, really pulling in the Revit files into the GIS along with legacy CAD data, so that literally every business unit in San Francisco International accesses the data from this spatial data infrastructure. I mentioned this is Schiphol, this is Amsterdam. They're actually monitoring 80,000 assets in real time. And so you can see the digital twin that they have on the right-hand side of all of the electrical, all of the physical plant, every elevator, every escalator, every moving part is being monitored. They have it connected to their SCADA systems. They have it connected to their asset control signaling and monitoring systems. And the point that they're really after is how do they do predictive maintenance, so that if I have an asset that is beginning to fail, I don't want it to, if it's an escalator and it fails when I've got hundreds of thousands of passengers, I've now created a huge issue for all of my passengers. And so they want to know ahead of time that there's going to be a problem so that they can send a maintenance crew in the evening when it's less busy to repair that, and so it doesn't. So literally for every asset, they're really looking at monitoring the state of that asset in real time so that, again, they can do predictive maintenance. The types of things that we can use, again, on the modeling side, on the airport side, we have much more experience, I think, with airports and digital twins than we necessarily do yet on the sort of linear space. But you can use literally the digital twin to look at terminal design, passenger flow analysis, on the outside ramp optimization, and certainly as we add more and more passenger volumes to our airports, they're going to have to become much more efficient. And so on the airport side, they have what's called collaborative decision making, which is basically the three main players at an airport. You have air traffic control, you have the airlines, and you have the airport itself. And typically, they had very little to do with each other. And the concept of collaborative decision-making is those three need to come together. They need to share information, ultimately with the concept of optimizing performance. So in fact, what they have found is that through collaborative decision-making at an airport, they can reduce the taxi time from between 1 and 3 minutes per departure. So critical way of really using the digital twin, if you will, to do these modeling scenarios. How do I identify, how do I change the processes to help be more efficient? So not only, and I think, you know, we're really seeing the beginning of how we do that on the linear side. So again, as I mentioned, if you think about all of that, that's a spatial data infrastructure that allows Caltrans now to do corridor studies, safety studies, literally any number of operations and ITS improvements, and really model those out on a real digital network. As well as how do we do a better job of really public transparency so that we can inform the public of what these projects are going to look like, and how do we bring all of that information together. So as I mentioned, those white lines are Caltrans linear referencing systems, so I can pull in all my crash data, my pavement condition data, all of that can be overlaid and integrated into ultimately this digital twin. So back to the original, my original concept. This is Europeans, when the Europeans talk about BIM, what they're really talking about is whole life cycle information management. And it's actually a requirement in pretty much every country in Europe that they have to follow BIM level 2 standards. And really it is this, how do we better manage the data through the entire life cycle? So everything under the orange curve is the potential savings, because as we all know, when we move typically in our transportation organizations from one department to the next, we have a tremendous amount of data loss, and we recreate those systems. And so the opportunity, that 15 to 25% savings, is that entire area under the curve there. And that's the opportunity that we need to capture to deliver greater bang for our dollar on infrastructure. So again, if you think about this, and Caltrans does not call this a digital twin, they're very specific about not, what they're really saying is they are creating the digital data infrastructure, and literally and they will have this for their entire network. And again, it doesn't require, it's actually built off of not only the BIM, the Civil 3D, but then also LiDAR, and in their case they used Ladybug, which is the digital video. So what you're really doing is you're creating a lifelike, literally infrastructure upon which you can overlay all these other digital elements. So, and with that, I'll go ahead and close out, and so thanks. Okay. So any questions?
If you have a question, please use the microphone if you can.
All right, well, I've sold all of you, so I'm not.
I do have one question.
All right.
I do have a question.
Okay.
I'm glad you showed all the physical representation. You talked about the fact that you went to the need of the customer, which is on-time departures, ramp optimization. That is the value, isn't it, of digital twinning?
Right.
And I mean, was there quantification of that benefit? That's question number one. And the second one is, part of the digital twin definition, at least in my head, is predictive and proactive analytics.
Correct.
Seeing things before they can happen, because you can leverage all of that knowledge base.
Yeah.
I'm sure you have the data to do that. Have you tried those?
Yeah, so that's a great question, and obviously we wish that every project was sort of that kind of a scientific comparison. Unfortunately, quite often they don't do that. We don't have those metrics, but I agree. I think that and again, I just want to emphasize, I see a lot of agencies building digital twins because it's the latest shiny object, and without really understanding kind of what that business need is. And I think that's really critical, that you need to understand what you're going to use it for and how you're really going to judge your performance on, because it is, for Schiphol Airport, I mean, you're talking about millions of dollars to build that digital twin. And in their case, they would be the first to say that they think it's well paid off. And again, it paid off because of what was avoided. That is, the failures that were avoided and the risk management, if you will. And I think that's one way to measure that is, what have I avoided, and what failures have I precluded. But yeah, I think we need to do a better job of the before and after, and to set those up almost as I wouldn't say scientific, but certainly good data, good measurements, and so that we do understand the return on investment.
Thank you, Terry.
I've got one question.
Yeah.
All right.
So, Terry, we're working to make the data more interchangeable through data, common data standards, maybe working with this. Do you think that's going to, introduction of data standards, that different, tools?
Yeah.
Is that going to make it better for us?
It will. Let me a little caveat. So I would always like to say our goal is to make it a seamless process. I have people back at Esri that slap my hand every time I use the word seamless. So it will probably never be completely seamless, but I do think that standards, IFC is going to help a lot, and I think that's going to help. There's always going to be a little bit of, but I think that we're all moving. Generally, most of the companies, and the examples that you saw there, Utah, basically bringing their contractors together and saying, look, we've got to figure this out. We have to make this work. We want to be more effective. We want to be, we want to do this better. And I think that from my perspective, the industry has a large role to play in terms of really stepping up and solving those problems and making it easier to move. And certainly that was a lot of our initiative with Autodesk to make that, and we've made the same offer with Bentley, and hasn't happened as of yet, but we certainly are able to pull items from Bentley and as you saw, the pay items and so forth, and move those directly into the GIS. But I do think industry needs to maybe step up a little bit more to make that a little easier.
There's one more question for you.
Yeah.
Terry, when you go back to residents and you talk to the folks across Esri, where else, what other sectors are in a similar place to transportation industry, and what could we benchmark ourselves against in other sectors in this?
Yeah, so it's a good question. And where I see, so as I mentioned, certainly in transportation, airports are the farthest ahead by far. And they really, because they're all going through capital improvements, they're designing new terminals in Revit, it's very easy to move forward. The other industry would be the utility industry, and I would say that many of them are really beginning to build the digital twins, much like Schiphol has done. So how do I build a digital twin so I'm monitoring all of my electric, my gas, my infrastructure in real time, and literally we see a lot of that on the utility side, and I think I would encourage you all to take a look at some of the activity on the utility side. The other thing I would encourage you to do is, quite frankly, the Europeans are so far ahead of us on this, and it's again, I think because it was mandated, and they have a little bit longer run at doing it. There are some phenomenal examples in Europe of really doing this the way it should be done, and very effectively, and they are. I can't say that every project is meeting their 15 to 20% savings that they would like to get, but certainly a large number of them are, and some of them are, they actually do have good cost data on that, on the savings. So, yeah.
Thank you, Terry.
All right, okay, thank you.
So that was an excellent presentation. Some really key points you make is the hype cycle. You know, something that I've always wondered is without value, you know, an idea will die on the vine, and you really, digital twin is the hot, you know, buzzword today. There's investment going in, but soon people will be asking for returns. And it has to be use case based and very well defined. So thanks for that caution there. And I think the collaboration between all life cycle phases is a key point that you make. And certainly utilities, I know from my experience, power and gas, specifically those two have done significant work in the linear infrastructure space. So I would say that I agree with, echo your thoughts there. So the next presentation is by Bruce Aquila, and I hope I got the name right, Bruce. It's called Back on Track, How Digital Asset Management, BIM, and Digital Twins Support the Rail Infrastructure. A very interesting parallel, I think, right on cue with what other sectors are doing. Bruce has been with Hexagon, formerly Intergraph, for 38 and a half years. Let's call it 40, Bruce? 40? Yeah. He is currently serving as an executive transportation consultant in the Transportation Business Development Group. Among his responsibilities are product ownership of the Hexagon Road Safety Manager product, technical business development, and consulting. His prior responsibilities include product planning, technical training, software testing. But I think the key here is Bruce does have significant transportation experience, having exclusively worked with state DOTs and MPOs, local governments and other transit agencies in asset management, linear referencing, and safety planning. And so without further ado, I think your talk will talk about how you bring it all together, Bruce. So looking forward to it.
It's kind of funny when Jag was introducing me and he said, 38 and a half, almost 40. Whenever I get asked that question, you know, and to give you an idea, a lot of you might not know who Hexagon is. Well, they bought my company before, and since we're in the presence of a lot of civil engineers, the company I used to work for was called Intergraph. And so Hexagon bought Intergraph. And so when they asked me that question, how long you been with Hexagon? I said, well, it's kind of twofold. You got to throw Intergraph in there. And I've been with them as long as Noah has come over on the ark. So it's just been a long ride. All right, so what I'm going to talk about today, it's very similar to what Terry was talking about a little while ago. And one thing that he did say toward the end of his presentation, I thought that was really, or just in the Q&A, that was interesting was Europe is farther ahead. They're a lot farther ahead than we are domestically in the States. And actually, the case studies that I'm going to talk about later in the presentation are all European rail companies that have looked at how to utilize a digital twin. And I do think, kind of along what Jag said, it is use case based. You have to have a business case for doing this. So with that said, we'll get going. And this is what we're going to do. You know, just we'll have some brief introduction. But then one of the things that I want to talk about is a digital twin to me, in and of itself, it's no big deal. All right, it's a pretty picture, right? But what value does it bring to the enterprise? That's the big question. And to answer that question, you have to look at some of the impacted systems / stakeholders. So I really think to derive value in what we see at Hexagon and what we've seen with some of our customers is that value is how you unify the enterprise in a holistic fashion. And that's where I think that a digital twin can step into a space and really bring value to these silos of excellence. And they are excellence. And we're going to talk about some of the systems in some of these case studies. Asset management systems, BIM systems, because that's kind of like the overarching theme of what this session's about, and maintenance and operations. So there's several things. All right, so, but there's some common challenges, and I think you can look almost across any industry. One of the industries, I know Terry mentioned utilities earlier. Well, Hexagon's a big company, and we have a division that does process plant and marine systems. You know, they got miles and miles of piping, you know, and they've got to manage all those assets. Well, they're one of the divisions of our company that are looking heavily, that industry is looking heavily at implementing digital twins to help them kind of, as Terry and Jack both mentioned about, you know, what does the future look like? I mean, how can we make this future, I don't have a problem with using the word seamless, you know, but how can we seamlessly transition from one place to the next place to the next place? What's the best avenue to do that, and what's the most cost-effective way to do that? So, you know, the biggest challenge, it doesn't matter what industry it is, you've got a lot of information you've got to be able to assimilate. And, I mean, just, Terry mentioned several of them in his last presentation. You know, and they all play a role kind of in the structural framework of these quote-unquote digital twins. And also, too, it takes a step, you know, it goes a step farther. Process automation, which is, I think, a big use case, and there's various aspects to that. There's not just one type of process automation, but there's several different types of processes that can be automated. So that's something that has got to, the digital twin has got to bring value. And most of those processes are usually residing in these operational areas. All right, and technology, you gotta have technology. You gotta have technology to do it, but also there's technology you gotta integrate. One of our divisions is, I don't know if you guys are familiar, maybe show hands, Leica Geosystems. Anybody here heard of them before? Well, they've got a lot of sensors. They make sensors that actually can stream data in real time back into operational units, command and control centers, just for various purposes. So being able to utilize that data in real time and see how it can affect the state of where we are and the state of where we want to go. Leveraging technologies to make use of that information. And there's other types that we'll talk about. And what benefit is it possibly going to bring? You know, one of the things it can do is provide insights maybe that you've never been able to see before. You know, in a cohesive manner. Like we say, we've got these silos of excellence, but they do have a nexus between them, and that the digital twin can facilitate that nexus so that they can make kind of congruent decisions together. All right, let's move on, and this is kind of for the context of what we're going to talk about, you know, for the next few minutes. These are some of the systems that we're going to touch on. These are critical systems for a successful deployment of a digital twin. Asset management. I mean, that's a big, after design build, I mean, asset management is at the crux of the life cycle of any asset that practitioners in this room are responsible for. So how do we, and now with good thing, and mentioned earlier too, a generational bill. And that affects many modes of transportation. We've seen like a lot of our transit customers. They're trying to figure out how to use all this money that the IIJA has allocated for the various things that they can potentially do. But that also on the DOT, the MPO, the state level, the highway, there's just you know, a generational opportunity really to enhance the value that you provide to the constituents in your planning jurisdictions. All right, and BIM. BIM's important because BIM describes the future, and that has kind of been alluded to already. You know, you can look at scenarios in the future. If I do this, what effect does it have? in this, potential project area. Also too, again, and I think the gears are a good illustration for this. And sometimes I'm a little remiss to make the digital twin the big one, but there's a flow of information in and out. It can't be a one-way relationship. These systems, these operational systems that are participating need to derive benefit or derive value. And we're going to look at that in a little while, those use cases. And last but not least, maintenance. Asset maintenance, that's a big thing. That's a huge thing. We've got dollars, tax dollars, that we've got to try to do the most we can with as little as we can throughout, the life cycle of that asset. All right, let's move on. All right, the digital twin. And we really think, and what we've seen with some of our customers in Europe, is that it really can play a big part just in improving the overall operations of rail organizations. Anything from planning, real-time feeding of data into this enterprise collaboration. Also to an area, and I'm not going to address this as much, but even in security of facilities, that's a big issue. If you'll think, let's say, for instance, rail subways, that's a huge issue, being able to secure stations, platforms, transit like buses, bus stops, being able to monitor those in real time and to be able to get feedback in. So heaven forbid there's an incident, being able to deploy and dispatch the appropriate personnel to deal with whatever could potentially occur at that. And just to use a quote from German Rail, because that's going to be one of the use cases that we look at, they specifically told us they use a digital twin to predict outcomes. That's one of their biggest drivers or their use cases, as Jag was mentioning earlier. All right, and since everyone else has had a definition of a digital twin, let's go 3 for 3. This one is from the Digital Twin Consortium, and I'm not going to go over every aspect of this, but I think the first overarching sentence is pretty good. It's just a virtual representation of the real world, the entities in that real world, but beyond that also processes. Processes that occur in reality. From inspections to maintenance to security. All of those collectively are a component piece of a digital twin. And they're synchronized to a specific time period and a specific data fidelity. So those are all that's a good overarching definition of what that is. Now, we've kind of got a little take on it that we call, and this kind of illustrates a little bit. And again, these are some general things to set the stage. Well, I went forward too fast, but do I have a reverse button on this thing? Yeah, there we go. All right, so really it's we call it a smart digital reality. You got two worlds, you got a physical world and you got a digital world, but those two together combined form one reality. And that one reality needs to be interactive, real-time, flowing, historic, present, and future. So you can imagine this is just a series of feedback loops that can be that are constantly in motion. So again, this provides a new line of sight to ever-changing situations that the implementers of these things are looking to address. And again, it's got to be process-driven. I think that's real important. It's nice to put all these things together, to look at them, even maybe to do, say, a public presentation. But if you can't incorporate your operational processes into this and address those, then you're not deriving the maximum value from them. All right, so let's start with the first system of interest that we deal with, and that's going to be kind of asset management. So this is just simply a typical rail system. These are the things that you're going to see. You've got switches, you got power lines, which that's really especially big over in Europe. Their electrification is very sophisticated there. Signals. You've got poles that they have to account for all of these things. But then you've actually got the physical infrastructure itself. So these things all together form the reality, the physical reality that these rail organizations and rail system providers are trying to manage. All right, and just a couple basic tenets, asset management, it's driven by operational rules and the data that you have. It's going to, one thing that has become very, very prevalent in the last 10 to 15 years is the locational aspect of that. Now, everything has a location. I can think of a bus stop. One of the things they manage an asset at a bus stop is a trash can. They've got that in their asset registry, in their asset management system. And really, the asset management system provides almost the basis for every underlying function, operational function that a rail provider goes through. And again, these are some of the areas, in that enterprise asset management. And the reason this is up here is because the processes have to be accounted for and utilized and leveraged within the context of a digital twin. And those are just some of the things, your assets, the maintenance, because we've talked about, big part of asset management is preventative life cycle maintenance. Where's our potential point of repair? Where's our potential point of failure? All right, and business processes too. There's processes as asset management, and those are just a list of several of them. But this actually extends beyond these some of these back office systems. We can actually take a step back to the actual collecting of the data itself. This plays a role actually in the formation, the definition, and the ongoing life cycle of the digital twin. And this just is an example of a rail organization, German Rail. They've got one of those Leica sensors on their rail car. And what they're doing is they're going out and they're collecting asset information, infrastructure information, and simultaneously they're collecting panoramic imagery. Now, what's important about this is they're able to do it like at 37 miles an hour, which means one thing, they don't have to necessarily disrupt service operation. See, this is part of the holistic aspect of this. By being able to collect your data like this and streaming it back, you don't have to, and still meeting your scheduling objectives. All those processes factor into the overall implementation and deployment of a digital twin. All right, let's look at another aspect, and that's just simply BIM. There's been a lot said about that in morning sessions this morning, kind of some of the comments that we've looked at earlier. And again, a lot of times BIM is thinking about cause and effect for the future. Here's our reality is now. What if I do this? What is the potential impact or effect? And there's really multiple aspects that it has a cause and effect on. What we're going to do here is look at a train station and just some of the effects that being able to incorporate BIM, what you see in BIM, into that digital twin. And those are some components that go over and above CAD, because a lot of times we think of CAD and modeling, what we have in either a DWG or a design file, in a 3D, and then boom, rendering, shading, and everything. But it can be a little bit more than that. It's some of those other things. So what we'll do is we'll take a look here, how within the context of a digital twin, we can come in, we can look at the station, but also too, we've got a maintenance request. There's a problem with an escalator. So now we know we've got to be able to go and communicate back to the asset management system. Number one, do we have that part in stocks? We have to look at our inventory management within our asset management system. Number two, if we don't, is it back ordered? Or even before that, is this part under warranty? All of those things collectively tie together, and the digital twin is a way that kind of we can facilitate that. look at the engineering drawings, the CAD drawings, those can all be overlaid, your as-builts for these things. They all fit congruently together. All right, another thing is data acquisition. This is an example of collecting data within a subway station, just using a handheld device, walking through that station and collecting information. Now, how is that important for asset management? Well, one of the things that you can do is you can compare what we say we have in our asset management system to what's there in reality. So that's a good nexus of verification. That's helps to automate that business process. And there's other ways that you can do that. A methodology is location. You know, coordinates of what you see in these LiDAR files compared to what the coordinates in the asset management say for a specific asset. So that's very essential as far as being able to tie all of these things together in a holistic approach. All right, so let's look at a couple of use cases now. The first one is Swiss Rail. They had before we worked with them on this project, they had a very small digital twin for one track and one subway station. That was it. That's all they had. And the reason is they had some serious challenges that they just didn't know how to address. One of them is they didn't really have any idea how to link their asset data with data in a digital twin. So they didn't know how to take, I think it was either them or German Rail, I get them all confused. Their asset management system, they weren't sure how to tie what was in there to what they had in digital reality. Because, you know, if you think of your asset management system, I mean, it does have a spatial component, but it's really, the majority of it's a back office system for work order management, contractor management, resource management, inventory management, and inspection, just all of those things. But how do we tie that into the physical reality of the world? Yes, you do have mobile inspection apps in most asset management systems. So they wanted to try to figure out how to tie those together. They wanted to also be able to do queries against their infrastructure within this context of a digital twin. They didn't really have an idea of how to do that. And they also want to be able to link asset management to BIM, kind of similar to what we saw in that last example of that subway station. All right, this is the study area. Remember now, they had one line and it was one station. So what they did in their initial pilot, it was 372, almost 373 square miles. And this was really a significant deviation from anything that they had done before. So, you know, they were biting off a pretty big chunk. And this is some of the data resources. These are the resources that they had, which actually, too, some of these are completely outside of their agency. They had point cloud data for the railway, for the actual line itself. They had point cloud of highway data, road data. They had BIM data for light poles, ticket machines. They'd already built these things up and track information. But they also had data that they had gotten from the Federal Swiss Topo Agency. So they brought in 3D buildings. They brought in digital elevation models. They brought in federal imagery, just a bunch of different information from outside, but it was valuable to what they were wanting to do and really for the expanse of the project that they were looking at. All right, so what you see here, those are all the ticket machines in Swiss Rail's network. So what we'll do is we're going to kick off a video here and we'll talk a little bit about that. Okay, so we're going to zoom in on an area. Again, that's all the stations are the ticket machines. And this is all browser-based too, so they're streaming this from servers. They're bringing in their electrification from a utility GIS system called GTEC. So they're overlaying that with all this LiDAR data, the elevation data, with the imagery data. Now they've driven the actual alignment itself. You can see there the electrification data in addition to the LiDAR data. So we're zooming into another area here, just kind of show you the scale of the project, give you a different orientation. And again, this is via a browser interface, so there's really no training. There's not a lot of training for the operational users. So we're going to go in around an area, and we've got a station loaded. We've got a BIM model for the station. You can see right there and for the surrounding area. Those are 3D buildings from that Swiss topo data repository. All right, we zoom in. And it takes, because they're streaming this data from their servers live, so it just takes a second to catch up. So you can see there's a ticket machine. That's one of their ticket machines that they have a BIM model for. Integrated together, they can do inspections through here. Now they can look at electrification, the current electrification that they've driven. They can pan down the line. And they can look at that within the context of a BIM model too. So they're able to pull all of this information together and use it simultaneously to do different types of analysis. They could do right-of-way infringement. They could do vegetation. Now they're bringing in the federal LiDAR data. They're classifying it. You're looking there. They've got it classified, and they're just using the attributes. We've got intelligence mechanisms set up to classify, say, based on the height. And so now what we're going to do is we're going to look at another area. We're going to come to an area that's a tunnel. So we're zooming into that. And now we can look at that tunnel. You can see that they can look and monitor for any type of structural deficiencies that they see in here, any type of problems with the concrete. And now what we're doing is we're looking in 3D. We can actually measure. They could do a measurement in 3D. They could assess like degraded areas even here. And we can turn and we can spin it around in 3D and look at it. And then we're going to exit the tunnel. And we're going to go back out to the macro area, the study area, where we're looking again at the federal LiDAR that was collected. So this is just an example, one of the examples of how Swiss Rail was going to merge all of these resources and some of the applications that they wanted to use it for in a digital twin. Now we're looking at the tunnel just from a different perspective. All right. Here's another aspect of the project. In this one, what they're going to do is they're going to mesh a BIM model of a station that was generated out of AutoCAD. They've got LiDAR data there with it. So you can see here, we'll zoom in to that station, and now we'll turn the LiDAR data off so we can look at the information that was collected right here. You can see the ticket machines, the platform, there's the waiting area for passengers. And then we'll look at just rotate around, look at interaction with the other areas, other affected spatial areas. And I'm watching my time trying to get through this. We got started a little bit late. So we're going to zoom in now, just look at that. And it gives them just a unique perspective of what of the data that they've got. All right, the next instance is German Rail. This one's a little bit more comprehensive. They had about a 15-mile area or section of track within Hamburg that they wanted to build a digital twin for. They wanted to be able to run that suburban train in an automated fashion. They had to be able to create a high-density map of that environment, and they had to implement sensors along that 15-mile stretch of the track alignment. And they wanted to also, here's the big thing, they wanted to be able to extract anomalies from data that they'd collect as they drove the center line. So this is a data verification workflow. Again, goes back to what Jag was saying. There's got to be a use case. Otherwise, all you're doing is looking at a pretty picture. Oops, wrong one. And this just shows you the line that they did this for. Again, it's about a 15-mile and had multiple stations along that. Here was their big problem. Again, You know, they had, again, these islands of excellence that they needed to have, that they had a logical analytical relationship for, but they couldn't quite piece how to do this in real time, looking toward past, present, and the future. So that just shows you kind of the architecture, you know, how they funnel stuff in and out of the digital twin. So they use the digital twin to break the silos down. So that, in addition to, you know, the change detection and verification, they needed to break the data silos, and this was a good way for them to do it. And again, one of their big key takeaways was this has to be process-oriented. So we've got to be able to account for business processes. And another thing is they wanted this to be the anchor point for asset management. All right, so just a sampling of the data. They had point clouds, again, imagery. But, you know, a lot of times when you look at point clouds, it's kind of hard to distinguish. Even when you classify it sometimes, it's hard to distinguish and get everything correct in that. So they had imagery that was synchronized that they wanted to use that also. But in addition to that, they had, and we'll look in a minute, they wanted to use that imagery in conjunction. So this is part of their digital twin along this 12.5-mile sector. So what they're going to do down here is they're going to just take a right-of-way infringement measurement, you know, because sometimes there's just things that change over time, you know, from past to the present. So they can use that to verify. They can look at vegetation too in relation to power lines to see if that's, you know, you see an infringement there that's going to affect performance. Now these are points that they've got tied to the imagery for the area. So now they're going to bring in the imagery into the workflow, into this business process. So they can also do, the measurement that they're doing is against the LiDAR data. So the LiDAR data is basically the three-dimensional data, and the imagery is just the cloak for it to provide better context for the analyst or the operator that's, you know, has to make an assessment of this given section of track. And again, you can spin it around in 3D. You can see the measurement vectors are held in 3D. Again, this is browser-based. So you don't have to have a thick client or anything like that necessary to do it. It's easier to deploy. The cost of deployment is much cheaper for them. So they're looking, now they overlay the LiDAR. Okay, another example is, this one is really interesting because the next couple are going into how much time do I have? 2 minutes? Okay, so let's start it. So what we're going to do in this one is we're going to look at change management. They have several sources of LiDAR that they merge together, and one of the things that they're going to use for verification too. They've got a structure. They want to check to make sure, do we have adequate clearance on this bridge that's carrying the rail? Because heaven forbid, if there's a bridge strike, especially if one of the trains is going over the time at a given time, that could be a catastrophic loss of life. So here they've got, you know, LiDAR from a couple years ago and just doing a basic measurement in it. And now what they're going to do is they're going to bring in, after we get done with this measurement, it is easier to do this, to talk for longer than, we were talking about this at lunch, you could talk longer than you think you would. Here's a file that was brought in, a separate file for a project, an engineering project 2 years later. Now also we're linking to the vector data in this digital twin, the asset information, and off that pole we have a trigger to go ahead and kick in a BIM model for it. And I'm going to fast forward through that, and this is just some of the data that was trained, that the intelligence was trained to classify and figure out what's in there versus what we say we have, but also to find where those anomalies are. And so I'm going to look at this last example for UK Rail because I think this one is good. They just had so much data, that was a problem in and of itself. But on this last example, again, what they did is they classified the LiDAR data to look for problematic areas. Again, you know, because the workforce management, sending people out there to inspect, it's costly and it's dangerous. But you'll notice up there that toward the bottom, that blue category, that's other. That detected where the anomalies are, that they could look at this, they could bring in other data resources, and then they could deploy without having to send an inspection team out on seek and you shall find mission. So in summary, digital twins enable effective leveraging of silos of excellence, automation of data discovery and verification, visualizing assets and linking to asset management. Again, going back to what I said, a holistic enterprise asset management system. So we've got all of these pieces and we want them to provide a congruent integrated solution. Just overall improvement of life cycle asset management. Sorry it took so long, guys.
No, it's okay, Bruce. We'll take one question. So time for one question from the audience? I really appreciate it.
Fast, too.
No, it was great information. Lots of really interesting case studies. Thank you, Bruce. Thanks a lot. But, so we're going to enter our last one, but what I took away from Bruce's presentation is you can do all of this without a digital, you're calling it digital twin, but what is important is the digital twin is the central source of all the data. I think Terry mentioned this, and is a single source of truth on which you build optimization routines, you build your process workflows and things of that nature. So it gives you something to build upon as a single source of truth and do your simulations and optimization. So next presentation, it's kind of a hybrid. We have Aaron Costin originally presenting. He couldn't be here. He's on paternity leave. But David Unkefer is going to step in for him. Thank you, David, for doing that. And Aaron will still be in the room. We kind of did some magic with Gary, on the AVs, helped us patch him in through Zoom. So he'll be available for Q&A while David comes up here. I'm going to introduce both of them really quickly. You can come up here, David. Aaron Costin is an assistant professor at the School of Construction Management at the University of Florida. He has done a tremendous amount of work in BIM, especially BIM for infrastructure and bridges. He's doing a lot of work on emerging technologies, including digital twins. So he is the main author for this. And David Unkefer, many of you know him. He is Federal Highways is one of the prominent faces that built all and led the innovation charge that led up to BIM here. So thank you, David, for doing it.
Thanks, Jag. Okay. I also want to just mention, I hope I'm saying it correctly, Alireza Adibfar, who worked with Aaron on this project as well. Unfortunately, Aaron was selected. His paper was selected, but he's a daddy. He's a new daddy, so he's home doing that. I think he can hear us, and he can even maybe answer some of your questions. This is going to be a very abbreviated version of what Aaron provided us because we went over it together. So as you can see, it's about it's kind of a specific use case. We talked about use cases, right, and how those have to bring value. And in this case, he and his researchers looked at structural health, using a digital twin for structural health, in terms of not only maintenance but also real-time management, and you'll see that in just a minute here. So this slide, Aaron explained to me, was just primarily to make the point that we have a significant number of poor bridges. I don't think Federal Highways calls them deficient anymore because it tends to give people the sense that they're getting ready to fall down. But essentially, we have this shows that in certain areas we have some bridges that need some attention, and so it's with a digital twin and maybe the ability to put sensors on them that could help us begin to have a better understanding of how to address I'll call it the asset management side, and we're going to see also a real-time solution as well. So, okay. So this is just, I think, reinforcing the idea that, sorry for that little overlap there, but This just reinforces the idea that we do have a lot of bridge issues. That was the focus of what Aaron did in this research, or his researcher did, and so really the question he's trying to pose here is, like, if we have so many bridges that need attention, how would we optimize the use of the funding? Is it more of a keep good roads good approach, an asset management approach, or is it more of a worst first? We have to address certain bridges because they are more dangerous. So the idea is, can we use tools like a digital twin and the data that it can amalgamate to help us analyze how to better spend our tax dollars? All right, so this is a situation that a digital twin could also help us address. It's a bridge that collapsed because of an overweight truck, and it was kind of a confluence of bad things. Under different circumstances, it might not have happened, but a number of things together caused it to collapse. I don't know how to play this, Jag. Okay, wow, thank you, whoever did that. So just keep an eye on, okay. So what happened here was that the bridge did not fail, in the kind of the traditional, just span. It actually tipped over, and the reason being that it had an excessive load all at one time, the convergence of different things that caused it to tip over. And I guess really Aaron told me the point of this could have happened anywhere, but the point is that how would we prevent overweight vehicles from getting, from getting to this situation? How can we have the kind of real-time information, warning system, for instance, that would allow us to prevent something like this, because it is preventable with the technology, with the information we have today. And I think Bruce mentioned also, like, if you have a hit, like a hit on certain bridges, it's catastrophic, right? So how can we just be have more of a real-time approach using something like a digital twin? Okay, so all right, so then this slide is to just kind of demonstrate that the technologies, and I think this has been said well by the previous two speakers, the technologies are there. The different, the bridge management system, some of the sensors that create structural health monitoring, ITS systems that deal with how the traffic is moving and tell us, give us information on that, plus the modeling. The model is kind of the place where it comes together on the twin. So essentially the technology is there for us to create a digital twin, and so what we need to be thinking about is how to fuse that information. And again, I think that's been shown that it's being done. In my own hope, and the reason I asked the question of Terry is that it can be a little more seamless, a little more, not necessarily seamless, but just a little more, the sharing of information, so that we can fuse data models for various use cases. So, by doing that, we're going to be able to do a lot more. These guys presented some excellent use case examples of what we can do with that information. And I really think we'll be able to make the business case, use case, and it'll just keep growing. I think beyond the trough of disillusionment was the productivity, right? It goes down, but then it comes back up, and there's a productivity stabilization, and then, of course, things go through it again. So, all right. Oh, I'm not sure if I covered. Yeah, so the digital twin is that fusion of data and systems that will allow us to accumulate information Again, that's been said well, but this is all kind of a prelude to the work that was done by, I think, Alareza and overseen by Aaron. So, bottom line, we create more new, useful knowledge base, in this case for bridge operations and maintenance, and we then accumulate historical information that would allow us to do more predictive analysis, and resource optimization, and others mentioned that as well. This slide is just to kind of show the different systems that are contributing to the digital twin. I believe, again, this has been, they've gone over it, and Aaron is just reiterating it here. You can see in the top, you've got the sensors and ITS information, traffic data, the model itself. Down in the bottom left, the AI, the artificial intelligence, and then the analysis that leads to real-time monitoring, predictive analysis, optimization over time of how we spend the funds and the work that we do, and just better decision making. This is really is what was behind my question. That IFC, or Industry Foundation classes, is one standard among, it's a key standard that has now been adopted by AASHTO, and it's intended to move us toward a more exchangeable data situation. So right now, sometimes when we fuse data, we have to write APIs, we have to do kind of one-off solutions. Sometimes you have partnering. Terry said he's partnering with Autodesk and others, I think. So with IFC, the idea is to create a data standard that makes the exchange better, and that also will make it more durable, the information more durable over time, kind of like having a PDF, so to speak. So this slide is to just kind of show that on the left you have your ITS sensors and information. On the right you have your bridge structure. The University of Florida basically was able to link these data, these systems, using an IFC model, or modeling approach, IFC file approach. So what you see on the top left is the model that they created in order to kind of replicate how they would create a warning system for overweight vehicles. And so you can kind of see here that they have the virtual example of that model. They have the system interface on the bottom left. The sensor data that's coming in is represented in the middle and the bottom. And then they're showing you the real-time live loads that they measured. So basically, this is just the process. I think the left shows how the data flows into the digital twin, and the right is the process for how it decides if something is overweight. And I think this is just kind of the flow, the process that we were talking about, that demonstrates how it takes the information and runs it through AI with historical information, does some predictive analysis, checks the thresholds, and then the bottom line in this case is to the bottom right. You see a twin span that, in the top left you see the twin span, and it shows you that the structure on the left is green, meaning it's okay. The structure on the right, where the truck is warning you that it's overweight. So, and I think, what Aaron mentioned is this can be placed such that you don't ever get on the bridge. So that's the idea with an overweight vehicle. So, so this, just is to make the point that the benefit of such a digital twin system like this
would be both for preventive planning and operations in the top there, preservation of the bridges because we're protecting them from overweight situations that maybe create fatiguing and so forth. And then in the bottom, we're looking to take that information and create more multi-source connections of data that can help us make better decisions, both short and real-time and long-term. So the projected benefits are, I guess this is kind of the punchline, utilizing artificial intelligence for predictive analysis of failure and maintenance. So you're not only protecting the bridge in real time, but taking that information and predicting future issues with particular bridges, look at what-if scenarios, potentially routing of traffic based on the measurements that you get from weigh-in-motion devices that are placed at strategic places. Take that information over time and optimize your asset management, your budget and resource allocation, and then just enhance your network planning of bridges because you're gathering lots of data that can be through artificial intelligence, make better decisions about how to address your bridge network issues, and just generally feed into your bridge design process based on data, real data that you're using, kind of like a forensic, I think the last bullet. So this is Aaron and Alareza, who I think was the primary researcher. So I think we have a little bit of time, and Aaron is on the line. So if somebody has a question for Aaron about what he did with that, research and toward this concept of structural health monitoring, I know that's getting a lot of play. I've seen some international examples. So,
any questions?
Thanks, David. Can you all hear me? This is Aaron.
Yes, Aaron. We can
Okay,
hear you
perfect.
in the room.
if I missed anything, Aaron, please, if I missed a key idea, please chime in, but we're waiting to see if anybody has a question.
Right.
Sure. David, you did a great job. The one thing I can just add is with the live loading is, the reason that bridge fell that you showed in the video is because it was an overloaded truck on top of a fully capacity bridge. So if any of those factors, if one of the factors that contributed was not there, if the truck wasn't loaded, if it wasn't during traffic, if he wasn't on the outside lane, then that bridge can be, the collapse can be prevented. And so the objective and the idea here is we can incorporate all these different sensors and using the different thresholds of identification of the fatigue of the bridge or stress loading on the bridge, we can actually prevent all that stuff. And we can see the loading in real time and then use the weigh and motion sensors ahead of time. So for the demonstration purposes, we put the sensor on the bridge calling it the WIM, but in reality that WIM would be a mile or two ahead of the bridge. So we can force the truck to either reduce its load or take its time to avoid that certain passing. So the whole idea is here, we have all this information and incorporating it into a central server or system, which is under the realm of digital twin, we're able to achieve possibilities that we can't do with each of these individual technologies standalone.
Right. Thank you, Aaron. That was really a great summary. Any questions from the room? If not, I have a question, Aaron, for you. And I think this is an excellent example of, again, going back to at least the initial definition is that I put up there is single source of truth. I think all of the examples reinforce that. Simulations and predictive analytics based on dynamic data, sensor data that's coming into the single source of truth of the physical infrastructure. You brought home the point that you can actually use that to effect change in behavior of the system. Like in this case, if it's an overweight truck, where the use case shows, hey, you are overweight, you cannot go over this bridge. The closed loop for me is going in back to the driver, some dashboard through the connected vehicle technology and giving them a warning saying you're overweight, you need to take a detour. Yes, you can do automatic dynamic remapping. So my question to you is, in your architectural positioning for this, do you have a communication messaging going back to either the infrastructure or, in this case, the truck itself? So that's the two-way communication that really only digital twins can do, because you're parking all the relevant data inside that.
Yep. So that real-time sensor that we have those thresholds are what trigger any responses. So in this case, if you go back to that, the real-time data feed where it has all the arrows, this case, we sent it to the BIM model to show, overweight, stop it, right? And that can still, and with a dynamic loading, and since we can actually put sensors on each element, you can see the live loads in real time in color. But like you said, if we have smart cars, we could send that same signal to the cars, or if we have the signage, we can have them there. Exactly. The key with the digital twin is collecting all the data to make those decisions that are actionable.
Excellent. Well, with that point, we are 2 seconds away, so no more questions in the room. Great presentations. Thanks, everyone.
Thank you.